Hello, in this video we are going to see a very brief introduction to decision making with linear programming. The basic idea of linear programming is that if you have, for example, a company that sells two products, in this case printers and cutter, and this is the price that you sell, and in order to produce X quantity of printer you need X quantity of these containers with the part of this, and X quantity of group of people, labor. And in order to produce Y quantity of cutter you need this and you need this. And you have a certain availability. You have only 6 of these containers, you have only 6 of these containers, and you have only 10 group of people, which means that the quantity that you use here plus the quantity that you use here has to be less or equal than 10. And the problem that you want to solve is how many printers and how many cutter would be convenient to produce and sell in order to maximize revenue. In this case, revenue is simply X plus Y, but in general it's going to be price of printer times X plus time of cutter times Y. And you want to maximize this subjective to these three constraints. So this is the mathematical problem that we have to solve. If we want to see graphically what this represents, this is what is called the solution space. This is where you are going to find the optimum. And if you take this restriction, this constraint with equal, then you have this line X equals 6. As you have less or equal, then you have this semi-space, and here Y equals 6 is this, and with the minus or equal is this, and then X plus Y equal 10 is this line, and then less or equal is this. Because both are positive, this is the solution space. Now, what is the shape of this objective function? Well, this is three-dimensional, and then in the case that both are 0, so you sell 0 printer and 0 cutter, then you have 0 revenue, is this point. And then as you sell more and more X, Y, printer and cutter, you are going up. So you are looking for the maximum revenue. So if you see this from above, then this is the solution space, okay, in 3 dimensions, in 2 dimensions. And then here you have, for example, one possible optimum here that in 2 dimensions is here, and you get it selling 4 printers and 6 cutter. If you do that in 2 dimensions is this point, 4 and 6, and then 4 and 6, the revenue that you are going to get is 4 plus 6, 10, which is this value here, 10. Okay, of course you can have here another optimum, okay, and in general you find in all of this line that in 2 dimensions is this, you find the same value, 10. The most common mathematical approach to solve this is a simplex method, and I am not going to explain it now, but very briefly you go only, you don't have to get inside. You take the maximum slope here, and then you go on until you find the maximum. And you can use different software to solve this problem. For example, WinQSB, MATLAB, OPL. And in general, you have two products, but the prices are not necessarily one and one like in the previous example. They can be different, and the constraint, this value can be any value, and here you have the stock or availability. And in the example that we have seen before, you have printer and cutter, and these are what you use to produce this. But in another case you could have, for example, a painting company. So here one product that you sell is exterior painting for exterior parts of the house, and here is interior painting, and then this is what you need to produce the painting. These are the quantity. But in both cases we are talking about producing and selling things. Well, this is basically linear programming. The case of decision making is similar, but the approach is different. In this case, you have one product that is, for example, solar panel, and you have here another product which is photovoltaic cells. So in this case, what you want to do is not to sell this product, but you want to buy this product, because in your farm you want to change the conventional electricity, conventional energy. You want to use now solar energy, and then you want to buy this is one option and this is the price, and this is another option and this is the price. So in this case, this represents the cost of the investment. And then you have, instead of maximizing an objective function, here you want to minimize costs. And the criteria that you use are, for example, efficiency index, financial index or return on investment, and land use. So you have, instead of calling a stock here, you call it threshold, and then you want that this less or equal to 1, etc. You want to use only a certain amount of land, and you want a minimum, in this case, financial return or investment. So in this case, what you have is here solar panel and here photovoltaic cells, and then this, because it's less or equal, is like before, kind of like this. This one is less or equal, so you have something like that. But here you have greater or equal. So in this case, what you have up to now, you have this, but because of this, you have a line like this, and because it's this greater or equal, it goes in the opposite direction. So what the solution Spain is right here, is some of this point, but you can have more constraint. So basically, because it is minimizing, you don't get a point here, because this would be the case of maximizing. You are going to get a point, because it's minimizing, you will get a point, let's say here, or here, or here, and this is what you want to buy, and this is what you want to get if you minimize this function subjected to this constraint. So if these are the prices of both options, the cost, then what you have to do is minimize this expression, which is price times quantity plus price times quantity, minimize the cost subjective to this constraint right here. So this is the kind of problem that we want to solve, and in the next video I'm going to show you a brief simulation of decision making with linear programming. Okay, thanks for watching, and see you in the next video.